Welcome back, class. So in this section, we'll be reviewing Chapter 6, Section 6.3, Solutions Using Powders. Our learning objectives are to calculate the powder volume, diluent volume, final volume, and concentration of a medication. So solutions using powders. In the preparation of solutions, the active ingredient is discussed in terms of weight, but it also occupies a certain amount of space. For lyophilized freeze-dried pharmaceuticals, they are packaged in a sterile vial and used for reconstitution. This space is referred to as the powdered volume. So if you see a vial and there's not liquid, there's usually either a white substance. Most of the time, it could come as a yellow substance in some medication forms. But that medication in the vial is considered a powdered volume. So that powder has weight in it. So in order to add the diluent into that medication, you have to take into account that powder volume because it will change the concentration of the medication. So the powder volume equals the difference between the final volume, FV, and the volume of the diluting ingredient or the diluent volume, DV. So here's our formula. Powdered volume equals the final volume minus the diluent volume, or PV is equal to FV minus DV. So for example, a powdered antibiotic must be reconstituted for use. The label states that the dried powder occupies 0.5 milliliters. Use the formula for solving the powder volume to determine the diluent volume, the amount of solvent added for each of the final volumes listed below. So in these three problems, we want to know the diluent volume because we have the final volume and we have the powder volume. So 2 mLs is the final volume and the powder volume was 0.5. The final volume was 5 mLs. The powder volume was 0.5. The final volume was 10 mLs. The powder volume was 0.5 mLs. So what is the diluent value in order to get the final volume? So we're going to rearrange our formula. 2dV is equal to FV minus PV. So our regular formula is this one right here, which is powdered volume is equal to final volume minus diluent. In order to solve for the diluent volume, we have to first add the diluent volume. So PV plus DV equals FV. Now we want to leave the diluent volume by itself, so we're going to subtract by PV. So therefore, new equation is dV is equal to FV minus PV. Now we can set up our three problems. So our first problem was that the final volume was 2 mLs minus the diluent volume 0.5 mLs will give us a diluent value of 1.5 mLs. The next one was final volume was 5 mLs minus the powdered volume 0.5 mLs is equal to 4.5 mLs of diluent. 10 ml final volume minus powdered volume 0.5 ml is equal to 9.5 milliliters. So next example, you are to reconstitute 1 gram of dried powder. The label states that you are to add 9.3 mLs of diluent to make a final solution of 100 milligrams per ml. What is the powdered volume? So in this problem, you notice that we have the total strength in grams. We have a diluent 9.3 mLs and we have a concentration. So we're missing the powdered volume and we're also missing the final volume in milliliters. We have the volume in grams, but not milliliters. So that's where we're going to be using our concentration of 100 milligrams per ml to find out that final volume. So here, let's read this part. It says, to determine the powder volume, you must also know the final volume and the diluent volume. The diluent volume has already been provided. So begin by calculating the final volume. You can find the final volume using that final concentration of solution. So let's set up our ratios and proportions. So we know that 1 gram is equal to 1,000 milligrams, okay, from our conversion table. So let's set it up. 1,000 milligrams over X mLs, because this will give us our final volume, right? So, and our concentration is 100 milligrams per ml. So we're going to go ahead and cross multiply. So X times 100 is equal to 1 times 1,000. Divide by 100 milligrams to cancel milligrams and be left with mLs. So 1 times 1,000 divided by 100 is equal to 10 ml. So 10 ml is our final volume, not our final answer, because we're looking for the powdered volume. We can also find the final volume using dimensional analysis. So mLs is what we're looking for. So using our concentration, mLs over 100 milligrams times 1,000 milligrams per 1 gram times 1 gram, because that's what we have. This is our conversion factor, and this is our concentration. So milligrams cancel, grams cancel. 1 times 1,000 times 1 divided by 1 divided by 100 gives us 10 mLs. Now we can go ahead and use our formula. Powdered volume minus final volume equals, powdered volume equals final volume minus diluent volume. So our final volume was 10 mLs minus our diluent, which was 9.3. So 10 minus 9.3 is equal to 0.7 mLs of powdered volume. So before we move on to the summary, let's go over one more problem in our book, and then we'll go ahead and move on to the summary. Okay, so looking at our book, Sorry, I think you couldn't hear me. So let me just go ahead and re-say this. So number 4, it says that the label of a 2-gram vial states that you are to add 6.8 mLs to get a concentration of 250 milligrams per ml. What is the powdered volume? So the same thing in this problem, it's not stating the final volume or the powdered volume. And our answer is the powdered volume. But in order to get the powdered volume, we first have to find out what the final volume is. So looking at the problem, we know that there's 2 grams. So that's our total gram value, but we need to know the value in milliliters. So in order to get that, we're going to have to use the concentration of 250 milligrams per ml, okay, before we can get the powdered volume. So let's go ahead and move on to our whiteboard, and then so we can set up this problem. Okay, so let's just write down what we know. So we know that we have 2 grams, and then we're going to go ahead and convert that to our milligrams because it's easier for me. So we know that there's 1,000 milligrams per gram, right? And we want to know how many milligrams are in 2 grams. So cross multiply, x is equal to 2,000 milligrams. Okay, so we know that. Now we know that our diluent volume is equal to 6.8 milliliters, right? That's a point right there. And we have a concentration of 250 milligrams per milliliter. We need to know our final volume and our powdered volume, which is actually the answer that we're looking for, right? But before we can move on to our powdered volume, we first have to find out what our final volume is. So we're going to go ahead and use our concentration and the total grams that we know, or the total amount of medication that we know. So let's set it up as 250 milligrams per ml is equal to, and we already know 2,000 milligrams because we already went ahead and converted our grams to milligrams over x milliliters. And this bottom part is actually our final volume, okay? So that's what we're looking for. So let's go ahead and cross multiply. So we have 250 x is equal to 2 divided by 250. X is equal to 8 milliliters. Okay, and that is equal to our final volume. Now that we know our final volume and we know our diluent volume, we can go ahead and find our powdered volume. So we know our equation, powdered volume is equal to final volume minus our diluent volume. So then PV is equal to 8 minus 6.8. So PV is equal to 1.2 milliliters. Okay, so we had to do 2 different steps here. First, we had to use our concentration and our final volume in grams in order to find out the final volume. Okay, so we converted our grams to milligrams and we use our concentration. And then the final step was to find our powdered volume. Okay, so there's two things we have to do here. Now let's go ahead and do problem number 5 because it has to do with problem number 4. So let me go back to the book and show you what problem number 5 states. Okay, so problem number 5 states, in question 4, to make the final concentration 125 milligrams per ml, how much diluent must you add? So now we're changing the concentration, the final concentration. So we're changing the final volume. Okay. Um, we already know the powdered volume from the previous problem. So we need to find out this time uh, the diluent and um, the final volume because we changed the concentration, okay? So now two things we have to find out. The final volume in order to find out how much diluent we need in order to change our concentration, okay? So we're gonna go ahead and use the same powdered volume as the previous problem. Now we just need to find out the final volume and then from there find out the diluent volume, okay? So let's go ahead and move on to our whiteboard. So from the previous problem, we found out that the, change it to black. We found out that the powdered volume was equal to 1.2 ml. Now in this problem, we have a concentration equal to 125 milligrams per ml. Okay, we still have the 2 grams, which we know are 2,000 milligrams from the math that we did in our previous problem. And we need to find out the final volume and the diluent volume. Okay, so in order to get the final volume, we're going to go ahead and use our total grams and our concentration. Okay, so let's set it up. 125 milligrams over ml is equal to 2,000 milligrams over x mLs. And again, this is actually our final volume, correct? So we're going to go ahead and cross multiply. So x times 125 is equal to 2,000. 1 times 2,000 divided by 125. X is equal to 16 mLs, which in reality is equal to our final volume. Now we can set up our equation. So our powdered volume is equal to our final volume minus our diluent volume. Okay, so in order to find diluent, we have to add by dV on both sides. So PV plus dV is equal to FV. Now we need to subtract by PV on both sides. So our diluent volume is equal to our final volume minus our powdered volume. Okay, so that gives us that our final volume was 16 mLs minus our powdered volume, which was 1.2 mLs. Oh, I can't make it. Sorry. I ran out of space. So 16 minus 1.2 will give us 14.8 mLs. And that will be the answer of our diluent volume for number 5. And this will conclude my examples for this section. So let's go ahead and move on to our our final presentation. So let's move on to our chapter summary. So there are three common types of injections are subcutaneous, intramuscular, and intravenous. Subcutaneous and intramuscular injections are small volume injections given over a short period of time. IV infusions typically range from 50 to 1,000 milliliters and are administered in a vein over a period of minutes to hours depending on the volume. Syringe barrel size is selected by choosing the smallest volume barrel that will accurately measure the desired amount. Small volumes may be rounded to the nearest tenth or hundredth, depending on the accuracy of the measuring device available. Large volumes may be rounded to the nearest tenth or whole milliliter, depending on the accuracy of the measuring device available. Ratio strength examples 1 to 1,000 is used to represent the concentration when the amount of medication in the vehicle is very small. When a solid medication has been dissolved in a liquid, the units of measure for 1 to 100 ratio solutions are 1 gram to 100 milliliter. Electrolytes are measured in milliequivalents or millimoles. Milliequivalents represents the amount of active charged electrons, not the amount of medication by weight. Medications derived from biological sources are sometimes dosed in units. Units may be used to measure medication dosage instead of the weight. When a medication is measured in units, weight is not used to measure the medication. Insulin and heparin are the two most common medications dosed in units. Insulin is most often concentrated as a standard of units per 100, which means that there are 100 units in every milliliter. And that concludes our chapter 6. Again, if you guys have any questions, please feel free to message me and I'll get back to you guys as soon as I can. Thank you and see you in the next chapter.